Good morning, ladies and gentlemen. So today I'm going to teach you how to find the particular integral when the right-hand side of the when the right-hand side of the partial differential equation is a polynomial. Okay, that's what I'm going to teach you. Polynomial means it's x power n, y power n. Okay, the term which I have highlighted, the right-hand side of the differential equation. This question was asked by a lot of students. They have asked me to explain. That's why I'm making this video. Okay. So the trick every time, it's a very simple trick actually. What does it mean? Take this d outside. When I take this d outside, okay, what I'll get here is d squared is what I'll get here. Because d is taken outside, the whole squared is there, d squared. 1 plus d prime. D prime, or I'll call it by d dash, okay, d dash or d prime, whichever it is, the whole square into x squared y. Okay. So now if you see it, the next step of this thing is that I will keep this 1 by d squared as it is. I won't touch anything in this. Okay, I will write as it is 1 plus, okay, whichever I am having, I'll write it here, 1 plus d dash by d, the whole square into x squared y. Okay. Whole power minus 2. Okay, there should be a minus here because I'm raising to the numerator. So the only change here is that I had something in the denominator, I'm raising it to the numerator. When I raise it to the numerator, what is it? The whole square will become minus 2. Okay, the whole power 2 will become minus 2. I hope so. All of you will be aware of this. 1 plus y whole power minus 2. This expansion, this geometric expansion, you all know it. So it is instead of y, I will use another variable. Instead of y, it is 1 plus z whole power minus 2. Okay, if it is asked 1 plus z whole power minus 2. What is 1 plus z whole power minus 2? 1 minus 2z plus 3z squared, okay, minus 4z cubed, okay, like this, plus and so on. It goes like that. Okay, so this is the rule which you might have heard already. So now, what is in terms of z? 1 plus d prime by d. So what is it I'll do here is I'll use this geometric expansion. I have 1 by d squared as it is. Okay. Now, I will expand this using this. By the expansion, what does it mean? 1 minus 2 times of z. Instead of z, it is d prime by d. Okay. Next one, plus 3 times of d prime, the whole square, by d square. Okay, this plus and so on, it goes. Okay, so but minus, actually this term, it is plus means minus and so on. Okay, it will be there. So into x squared y. Okay, whatever it is there, I have written. But as you know, this d and d dash, what is this d stands for? The derivative with respect to x. D dash stands for, d prime stands for derivative with respect to y. This is a polynomial. How many derivatives it will hold? I have d dash and d dash square. Okay, so d dash of y, okay, because I have y squared, the partial derivative with respect to y. So only in this numerator, the derivative of y is 1. Again, when I use d squared of y is equal to 0. With this, what does it mean? With this thought in the mind, I can cancel all the higher powers. Higher powers in d, I can cancel. Okay? So I will wrap this part. Okay, so this is whatever in the remaining. Okay, in the remaining you can write it here 1 by d squared. Okay, multiply this x squared y. Then I multiply x squared y minus 2 d dash of x squared y divided by d. Okay, and this closes off. Now this term there is no problem. 1 by d squared of x squared y. Okay, I'll put a bracket x squared y. Now what is it I'm having here is this one. If you see derivative d prime of x squared y, I will write it here and then I'll rub it. So d prime means dou by dou y of x squared y. What is the derivative of x squared y with respect to y? It is x squared alone, because y with respect to y is 1. So only x squared I will get it. So I'm going to write it now. What is it I'm going to write it here is, okay, let me rub this first. Okay. Now what does it means? We are going to have here, when I derivate with respect to y, minus 2 by d as it is. Okay, 2 by d, I have it. So this one, derivative of partial derivative with respect to y of x squared y is nothing but only x squared as I explained. So now it's almost the last step we are entering. What is remaining here is 1 by d squared of x squared y minus 2 divided by d cube of x squared. So again, you need to be aware, 1 by d. You know what is d, isn't it? D is equal to dou by dou x. 1 by d will denote integral with respect to x. Right? So 1 by d will denote integral with respect to x. So in the first term, what is it I'm having? D squared I'm having. If you notice, 1 by d squared. So this integration, y I can write it as it is. Okay, y I can write it as it is. So now the question is, what is the integration of x squared, 1 by d squared of x squared? I told you the 1 by d is integration with respect to x. Okay, so it means that the twice, 2 times of x squared, 2 times x squared dx dx. So the first time integration, I will get it as x cubed by 3. Okay, again when you integrate, it is x power 4 by 12. Okay, so this is what I'm going to write it here. So this one I can rub it. So remember, 1 by d squared is 1 by d means integration with respect to x. So I'm having 2 times of integration. So the 2 times of integration is, what will I get here is this 2 times of integration is x squared is x squared, sorry, first time it is x squared, x cubed by 3, and the second time it is x power 4 by 12. This is what we'll get. Those who did not understand there, here again I will explain. 2 I'll write it as it is. Here it should have been x squared. Okay, adding out. I'm a simple step there. See here, x squared, I'm having d cube. 1 by d cube. 1 by d cube, it tells that, what it tells here is, the first derivative, first integration is x power 3 by 3. Again when you integrate, what is it again when you integrate? X power 4 by 12. Again when you integrate, what will we have here is, again when we integrate, integrate this x power 5. 4 will go to this next one. So 12 into 5 is 60. I'm going to substitute here. What should I get here is x power 5 by x power 5 by 60. Okay, this is what I get. So all these are explanations not required. Okay, needless for my students. Okay, so keeping on integrating, nothing but it's a simultaneous integration. That's it. The problem is over. Let me cancel this 2 with this. Okay, so 2 divided by 60. So the answer is x power 4 into y divided by 12 minus x power 5 divided by 30. Okay, the problem ends here. Okay, the particular integral of a differential equation when the right hand side is a polynomial. Now my question is, I have taken d outside. Okay, you are equally right. You can take d dash also outside, isn't it? See here, I have taken d outside here. Instead of d, you could have taken d prime also outside. If you would have taken d prime outside, you will get an altogether a different result. That is also a particular solution. How can we take both as the solution means? Remember this word, the solutions of a PDE are not unique. It doesn't need to be same. I hope so I'm clear with you, right? So this may not be this only solution. Okay, when I take this d prime, I will get it in terms of y power 4 into x squared something. Okay, all those things. It will change. Actually, the solution will change, right? Okay.